In today's video we are studying all things North Pole, what actually lives up there and how on earth do we know what lives up there. Hi everyone, my name is Elizabeth, I'm a marine biologist. It's my job to share about the weirdest and most wonderful sea creatures, and today is a festive themed episode where we are learning all about the sea creatures that you can find in the North Pole. That's right, today we are passing through the 7 levels of the candy cane forest, past the swirly whirly gumdrops, and we are heading to the most northern point on our entire planet. Which that didn't occur to me. Though I was researching this, I read the sentence that every direction from the North Pole is south. And then I was like, whoa, that's really cool because yeah, but then I was like, wait, is there no direction in space? So you're standing at the North Pole. Is it just up? Is it not? What is directions? This is a question for another day. This is probably something to do with physics and magnets and things. And today we are focusing on all of the incredible animal life as well as the elves and Santa Claus that you can find in the North Pole. What makes this particularly special topic to talk about, not only because it's near Christmas, but because as a marine biologist, the North Pole, there is no land. It is only water and ice, which is amazing to think about, but also like, whoa. And the ice there actually, a lot of the time it covers like the big ice sheets, but they're only about 10 feet thick, which I was like, what? Only about 10 feet thick? That's like, I'm going to reveal my height here, 2 of me. And yes, every time someone meets me, they do go, oh. Because it's only about 10 feet thick, there is a lot of movement, a lot of melting of the ice, a lot of sort of refreezing. And I am just going to say, as we get into the whole like start of the video, freezing, melting of ice caps, there is a lot that I could talk about climate change, how it's making it worse. We are not going to be talking about that in this video. You know, it's the end of the year and there's absolutely nothing wrong with just taking the time to celebrate, fall a little bit more in love, the sea life that is there, and then in 2026 we can start the year cracking and I can talk about more, if you want to, about the issues that's going on at the North Pole and the Arctic and just some of the stuff in general. But today it is just a celebration of the wonderful sea life that is there because they deserve the full love that we can give them and that space and time, which is what this video is going to be about. So the North Pole is unique and awesome in that sense that there is a lot of ocean and a lot of ice and a lot of movement with that melting and refreezing. But it also provides quite a unique challenge as researchers, as marine biologists, as people that want to go up and study the sea and the animals that live around there for a couple of reasons, not just one, but a couple. A big one is that because it's at the top, it's got the polar night and the very, very long summer, which is, it must just be amazing to experience and must be really, really bizarre. So that just means that for about 4 months of the year, it can be in like complete and utter darkness. There is no sunlight there whatsoever, which means that a lot of the time, if we are going to go and study, we have to kind of do that in summer. And also the reason for that is that in summer, that's when the ice is melting and actually provides a way through to get up and into the ocean and around there to be able to study it. And because of this movement, because in summer it's a lot more like melty and movie aroundy, and this is exactly what the ice is like. And then in winter it's like frozen, let it go. Then it also provides a challenge because we can't create anything sort of permanent there to set up as what would be a research station, a base that people could go to live for a bit, to then study and see what the sea life is. Unless you have magic like Santa and the elves, there's no way to keep a stable building, workshops and things up there ready to go. So it provides a very unique challenge. And one of the things that we do then to go up and study is expeditions, which if anyone is an expedition human, there's been on an expedition or is in charge of them and wants a science communicator, I am looking and trying to apply to all the things. I want to be on a research ship so badly, and I can share about all the wonders of it, please. So how do scientists get up there to study the different sea creatures if there isn't sort of a place to then stay when they're up there? Well, unfortunately, the Polar Express is pretty limited and reserved. It's very selective with the people that can catch the Polar Express, and Sanders Sleigh isn't very big, so they can't take many scientists up at a time. But if you are not going by sleigh or train in that way, then research expeditions happen on big ships. They build big ships, often icebreakers that can get through ice, and they can go up there, and on those ships they look really cool, have like labs and all these amazing equipments and places for the scientists to sleep and eat and like live on expeditions for quite a while. And I want to say about one that I learned about researching this because it was so cool to hear about. So the Polar Stern set off in 2019, and luckily you can like fly up to or helicopter up to places in the Arctic, and you don't have to do the full expedition. Or I'm thinking in the case of Polar Sterns, it got a bit interrupted by the year 2020. But it set off in 2019 for a 12 to 14 month expedition. And what its plan was is that they looked at all the ice on like satellites and studied how it moved and where the flow was going. And what they did is they built a ship that was going to then go along, and they looked online in the satellites and were like, which bit of ice here looks like a nice place to crash into? And they were like, that bit. So what they did is they took the ship while the ice was still melty in summer, and they rammed the ship onto the bit of ice, and they turned off the engines, and then they sat there, waited for the ice to refreeze, and then they drifted with what is called an ice flow, a new term that I've learnt, just a big bit of floating ice. It's like, woo, with the ice flow all the way sort of across the Arctic, going across near-ish, like the North Pole was the plan, was to drift with those big bits of ice until the following summer when they popped out the other end and then could come back and get back. Isn't that incredible? That must have been such it's just like such a cool thing to do, and also just one of those experiences where you're just like, what are you doing? You are going to just drift with the ice. I just think that's amazing. That's so cool. And then, isn't that so exciting? So it is easier to study creatures, I imagine, in the summer because you can see things. Again, polar night, darkness all the time. And for the sea creatures that come above land, either on the ice or above land, above the sea, I suppose, either on the ice or in the water, then we can, from those ships, use eyes and look out and see what creatures live there. There are some really cool, really well-known creatures. Of course, we've got the polar bears, we've got Arctic foxes, we've got things like ringed seals. And I'm going to rattle off a few cool facts about these big, fancy, awesome animals. I learnt this fact as a kid, and I still think it's really cool, that polar bears' skin is actually like black, and then their fur isn't white, it is clear, and it's the way that the light refracts into it that makes it then come back out and looks bright white. And they have 2 layers of fur to keep them really, really warm, which I think is really cool. The other thing I learned about polar bears was that less than 2% of their hunts are successful. Like, well, probably just bodged up the mic there. Like, poor things, like they're going out and hunting and only 2% of the time they get food. They must be starving. And the things that they hunt are things like ringed seals. Now these are really cute and they look really cool. And ringed seals have claws on the end of their fins, and so they swim through the water, and if there's just ice upon ice upon ice, they are marine mammals, they need to be able to breathe, and that ice is going to be blocking them off from coming up to the surface to breathe, which is not great. So they have like claws on their flippers, and they're able to make holes through the ice to be able to breathe under, and so then they can like pop out and breathe, which I think is just really cool. And there's been quite a few movie moments where the seal pops out and like, uh-oh, did you hear the cracking then? No. How old am I? There are also narwhals up there. Of course there are. Bye buddy, I hope you find your dad. I am a huge Christmas fan. I don't feel like I'm in a Christmassy outfit enough for this, but like, huge. Narwhals are really cool because they have this spinny tusk, but it's not a tusk. is a tooth. But narwhals don't have teeth. They have no teeth in their mouth, but their tusk is a tooth. And it's not just a tooth, it is a tooth that has some really cool abilities, like telling how much salinity the water has, which is how salty it is. And the more fresh water, the more melty ice gets, the more fresh water goes into the sea, and then the more freezes, the less fresh water goes into the sea, because it's the fresh water that's freezing out. And they can tell that because they do not want to get trapped by the ice. So as soon as stuff starts to refreeze up again, it sort of tells them to disappear slightly off into the more outskirts of the Arctic to go and find things. Isn't that awesome? So they're not toothless. They are, wait, I can do this better. So they are toothless, but they have a toothed tusk that measures seawater. Okay, glad we got that settled. Birds, they exist in the world, and they also exist in the Arctic. In fact, one of my favourite birds ever is up in the Arctic. And the reason they're one of my favourite birds is because when I went to the Isle of May, check out video here, never know which side it is, when you get off the boat, they tell you to wear a cap. Perfect, I collect caps because you have to put a cap on, because there is a colony of Arctic terns as you get off, and they're like, hey, they're really just territorial, we're keeping to the path, we're not stressing them out, but they have been known to swoop at you, but if you wear a cap, they won't. For some reason. So these beautiful, beautiful, gorgeous birds are Arctic terns. Now I think the Arctic terns on the Isle of May, because they do breed in Scotland, are the ones that are like, hey, we don't have to go all the way to the North Pole, you know, like we've got a nice island here and we've got some tourists that we can harass every now and again. Sounds good. But for those who want a bit less of a tourist vibe, they head all the way up sort of to the Arctic to breed. And they spend the summer there. So lots of light, love the cold, going on there. And then they do the longest recorded migration of any animal ever, and they spend summer in Antarctica. That's the other side. They then were like, hey, we're having a great summer, we don't want to deal with this winter, we're just going to go do the other summer, right? And so they fly all the way around the world, literally, and go down to Antarctica to then come all the way back up again when they want to breed again the next, in a year's cycle. My goodness. Arctic terns travel 44,000 to 59,000 miles a year. A year! That's 3 round trips to the moon. 3. They could fly back and forth to the moon 3 times. Houston, we have an Arctic tern. What? Now let's dive into the species that you can find in the water. So this whole big thing about this is a whole big thing. So the whole big thing about the fact that for half the year you are plunged into darkness and the other year you are in light really, really is a big deal for the whole ecosystem chain. And largely because at the start of most food webs, food chains, is things that make energy from the sun. So in the case of the ocean, it's phytoplankton. Case on land, it's things like plants, because there's no other input. You don't need a living thing to give that thing energy. You are starting with energy from the sun, which is already there. Energy is in the chain, and then it builds and builds and builds as you sort of go out from that. So when you have a whole environment where for the majority, like 4 months of complete darkness, and then depending on what bit of the ocean you are in, it can be up to, I'm just going to double check my notes here, 8 months. 8 months of no light. How on earth does that environment where the very core, the very base, the thing that sparks the life of everything else won't be able to, or shouldn't be able to, produce energy? Oh well, I have been researching this and I have discovered something. I have discovered it. No, I have not discovered. I've just learned. I can't believe I didn't know about this before. This is why I love this YouTube channel, because not only are you learning, I am learning. I am spending my time being like, whoa, I need to tell people on YouTube about this. Exactly that. I'm that animated alone in my office, like, whoa. So, ice algae. There are algae, like little tiny algae that live in the ice, and they remain in the ice during the winter, and as soon as there's a little inkling of light, they are one of the best species in the world that are adapted to photosynthesize at low light, which is really, really cool. So that during those 4 months of darkness, it's probably a no-go, but then as soon as that light starts to peek over the curved earth, the round globe earth, then it's able to go and start photosynthesizing. Now this is important because in the ocean, across the whole thing, oh, I could make a whole video on this. I had so many lectures on this. If you want a whole video on this, there's fancy graphs and it changes in different places. But a lot of the time, because there are different seasons and different temperatures and different levels of sunlight, there are things called algae blooms that really kick off a whole chain of events. And that is when conditions are just right. In this case, light comes back, where phytoplankton is like, yay, and are able to produce and reproduce in mass amounts. Algal blooms can get massive. You can see them from space, where they just go crazy and they're like, yes, this is our time. And in a very short period of space, a lot of energy gets put into the food chain and stuff sort of happens from that. Now this happens in the Arctic too, it happens in summer, but that is quite late in the day for that bloom to happen. And so what happens is the ice algae fills that gap in the food chain. The ice algae kicks this off in spring. It reproduces, it blooms in the ice, it goes into the water column, and it filters down and adds energy that way, and then you get this hit of phytoplankton. And so this is sort of sustaining the base of the food chain. And then it's got to be mentioned when we're talking about plankton and things, like this is phytoplankton, and then we jump up a stage and we get to plankton, so the plankton that eats the tiny plankton. Again, let me know, food chain, I could do a whole video on that. I might have done already, I can't remember. So our krill. Oh, and the other thing is my sister had a baby and then he lost his arms and his legs. Krill are really, really important. They can just absolutely, again, like the phytoplankton blooms, just go massive. You can have 10,000 krill in a cubic meter, and this sort of feeds a lot of the food chain. A lot of things like seals will eat this, but also we can jump right up to the big awesome whales. There's 17 species of whales that you can find in the Arctic. 17 split into two groups. We have baleen whales and we have toothed whales. Toothed whales, they have teeth, unlike narwhals, which only has one tooth that measures salinity. Gonna drill that in. These are ones that are more likely to go out and hunt things like fish and squid and that. But baleen whales have more like big giant plates. It's the whales, like humpback whales, the whales that is in Finding Dory, that are able to use those plates to just sort of gulp massive amounts, filter out the krill, num 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 the krill, and then do that again. I don't think there's any more stages to that. Imagine they poo at some point. But that's the cycle of a humpback whale eating. Moving on. So how do we know what is going on? Well, we have to also remember what is happening with this bit of water. We've got 10 foot of ice, and then we have water. And it is a lot. It is really deep and really cool looking around the Arctic in terms of like, we've got lots of ridges and basins and lots of really interesting things on the seafloor that can mean that there's lots of cool stuff going on there. Oceanographically, which is like the movement of water. But the ocean at the North Pole is really deep. It's around 4,000 meters, but I'm gonna say it in feet too because it's a really satisfying number. The number is 123 feet. Pretty cool. So not only are we dealing with light and different things, we are dealing with depth and temperature changes and pressure changes and light changes, even in this whole load of water. Classically, when we're going out to study what sort of lives in the water, we can use things like plankton nets, which we can drop at different depths, and we can drop at different sizes. So lots of different plankton are different sizes. So we have these nice thin mesh nets that get put in the water and are dragged through and bring back a load of plankton that you can then take away and identify and sample. Actually, if you want to check out plankton, you can go check out the Plankton Project. I'll put the Instagram in the description below. That project is run by Elizabeth Beston, another Elizabeth, always a win, who is just awesome, and I've known for a while now, sharing about all the awesomeness of plankton. So go and check out their site, because it's just really cool. So we can do plankton nets that way. We can also do trawls for fish, so putting a net out there, different depths, different sizes, and seeing what fish is caught. It's not going to be an exhaustive list of all of the different ways, because really there's so many different techniques to sample lots of different things in the sea. But there is one really cool way, or one new cool way, that I have been learning about and discovered a really cool thing that I want to talk about, that is like a really advancedness in tech. Advancedness in tech, that's right, terminology and sounds fancy. Buckle up, because we are going to be chatting. We're going to be deep diving into a very niche, very cool bit of science. I'm going to do my best to explain it as a science communicator. We have DNA. D-ribonucleic acid. I've said that with conviction, and I'm going to check it's right. It is right. So we are made up of DNA. It's the building blocks of like everything about us, and it is unique to each person unless you are an identical twin. They share the same DNA. But what we are using a lot in the time of scientists is RNA, ribonucleic acid. The main difference between DNA and RNA is that DNA, that deoxyribose, and RNA is ribose. There's a different like backbone. So the things that in DNA you see is like the strip with lots of the A, T, G, and C attached to it. That thing is made of a different sugar. And in DNA, that is really, really intact, because it really has to be. You know, we are being created by this. It is the thing that really is the code to create humans, has to stick around. But with RNA, what it's used for is used for lots of different things, including like messaging or transfer of different things. It's more of, in my head, you know, DNA is a building, RNA is more of like a text. It's like I'm walking into the place of work in the building, and RNA is all the text messages or the emails that are like, hey, can you do this? And RNA is going off and doing it. But this is a key difference to make between the two things of how we are being used. Because if you have DNA, if you have that work building, you have that company, you need messages and to go about and to get that work done. And so if you have DNA, you also have RNA, but RNA is not hanging around like DNA is. We don't need all of these messages to be kept, filling up the inbox. Our drives are getting full, and so they just don't stick around. They're not as long lasting, which means that the way that we're using this to study creatures is that we are looking for RNA in the water column. We are taking RNA out of the water, out of the environment, and we are looking at what that RNA is and studying it. Now, compared to DNA, it's not as like individualistic. You couldn't tell, I don't think, like what animal or like what like that particular bear has all this RNA, but you can use RNA and the sequences from it to tell what species it is. And the benefit of using that over DNA in some cases is that DNA can hang around for a long, long time. Jurassic Park, anyone? That sort of thing. And so you might be picking up a species that is no longer there. And what this is like a study to tell what species are in the environment and what is there now. And I just think that's so unbelievable. Like, isn't that, whoa, wow. We are using DNA in things like measuring polar bears' footprints. So if a polar bear is walking along, they'll probably leave a bit of DNA from their skin, a bit like Private Eye, detectives, but for polar bear paw prints. Get me involved in that. That sounds awesome. And that's where DNA comes in. Like using this technique for DNA is really good there, because with the polar bears, like you want to know what polar bear it is, how can we get information about that individual, how can we track them, how all that sort of stuff. Like that can be used for DNA with paw prints. That's so cool. So cool. Also means you don't have to get close and get eaten by a polar bear. Win-win. Now, I've told you about this like RNA thing. Why? Why have I explained this all? Well, there is a really cool and awesome creature that I want to talk to you about. And you might not think it's cool and awesome right off the bat, but stick with me because it is. This creature is not an animal and it is not a plant, though it is like a planty animal. It is a unicellular eukaryote protist. Stick with me. Now, protists are their own thing. The way that they're made up makes them different to plants and animals. I'm going to be honest with you, I don't know exactly what that thing is. I looked up a lot of stuff and I just worked out people were like, it's just different. I could be a better science communicator and look it up, but I'll do the thing that I'm going to say I'll do in lots of this stuff and say, I'll make another video. So they are completely different to these animals and plants, and these protists are in the water column too, and we've discovered this through the RNA processy things. But they have in their body a thing called a microbial rhodopsin. God, we love some complicated terms in science, and this is why I love being a science communicator, because we are going to break that down. So this protist has in its body a very fancy protein. Now protein, I always find protein a difficult term too, because it's like, well, is it like protein? What is a protein? I would just say in my brain, I think of it as like a thing in a cell that's really able to do stuff, like move and transfer and be put into different shapes, and it might be able to fling something or move something, and it's just like a really useful, very movable piece. It's like Lego in cells. And this Lego within the cell, this protein, is attached to a... Come on brain, you can think of the term. I know what the term is. Don't have to look at the notes. Chromophore. And a chromophore is a thing in a cell. Bear with me, I know I said thing, but it basically is a thing that is connected to this protein. And when it gets light, it starts doing its thing. It's like, yes, we have light, and it's able to make energy from the sun using, it like swishes on the protein, conveyor belts are running, and these protists are getting energy from the sun too. Like photosynthesis, but not photosynthesis. So these protists are not plants, but are like plants, and they can photosynthesize, but not photosynthesize. But it's really cool because it's not either of those. So all of these creatures are using techniques. They're using every ounce of sunlight that they can get. They are, during the winter times, they are going into like vegetative states. They are like just shutting down and going into the most low energy possible to survive those dark, cold winter times, ready for these spring blooms, all sort of chucked about by the sun coming back in and the ice melting and the ice algae blooms, and everything's churning up. And I just think it's a really awesome thing that there is so much life here, but it's all really, really like kept together by just these like adaptations to survive in such a like harsh environment. And because it's such a harsh environment, our discoveries of the Arctic have really gone hand in hand with that increase in technology. We are using and developing new and cool methods of technology and techniques, but we are still using other techniques that we have used before. So let's go back to the ship. The ship crashes into the ice freezes over, and how other people have done it, whether you've crashed a ship into the ice or you've sort of jumped off onto a more stable bit of ice for a temporary amount of time, you can maybe set up a miniature temporary base or a camp. Watch out for polar bears, because that's the thing that they might come hunting you if you're out on the ice. But you can set up ice stations, and so you could drill a little hole in the ice, and you can put things down, and you can lower it right the way down as far as you can to the seafloor and take lots of samples and do lots of things, which allows you to get measurements of things under the ice, or you can, on the boat as you're going along, put measurements down and use things to study that, because there's lots of still not covered. We need to talk about the fact that when you get down to 4,000 meters, there are things living on the seafloor, like rock pools, but 4,000 meters under the water, and they don't come out of the water. But there's lots of amazing creatures down there, and lots of things to study. And there's stuff that lives under the sediment, things in the mud and the ocean and the seafloor, and it's just so cool. And these creatures are particularly awesome because they are adapted to survive way down at the bottom. So how do we study the things that are in the seafloor, on the seafloor, all of that sort of stuff? Well, there's a couple of methods to take samples from the bottom of the sea. So there is multi-cores that you can take. It's like sending down a big cone, and around the edge of the cone, so the cone around the edge of this, there are about 8 cylinders, and you can ask the cylinders, hey cylinders, do you mind taking this sample for us today? Yes, we don't mind, thank you. You can set it so that the cores take different things. So you get a lot of information about a specific spot. So you can ask it to take a core of mud to look at maybe the metals that are in there, or the chemistry, or the pore size of the sediment, which is important for what could live in there and what is going on in the mud. Or you could ask it to take that core, to take the core of the mud, so you can bring back up any of the animals or microorganisms that are living in it. We also have, for sort of bigger samples, things called a box and a grab core. So a box core is a big metal box that goes down, and when it hits the bottom of the water, the weight of it sort of settles the device into the machine. See, doing some acting here. I'm acting like the box. And once it's settled in enough, there's a big scoop at the side of the box that goes under it and sort of seals it off and comes back up. A grab is like, if you've seen like a JCB sort of hook handle, it's 2 of those like this, and they're sort of spring loaded but open, and they go down, and then you pull the trigger, and when it gets to the bottom it like scoops it up and locks in, and then you can drag it back up to the top. And then you have a lot of mud and a lot of different creatures, including many worms, I imagine, which are difficult to identify, and things like that, to go back and look in at the lab after that. And I'm sure there have been just so many awesome species discovered about things in the Arctic, because there's so many new species being discovered all the time. But these techniques are very much, you have to be exactly above where this is happening for those to go ahead. Which means a lot of the time, a lot of the Arctic, again, being icy, being remote, being difficult to get to, are off the places that you can actually study. But we have also now developed remote operated vehicles, ROVs, which are like little underwater drones that you can go along, and they can do loads. They can like take samples, they can do lots of different bits, but the main like awesome thing that they can do is that they have a video camera, and because you can remotely control them, they don't have to go just straight down, which means that they can go down to loads of different depths. They can have a look around at what's there, spot fish, spot different things on the way down, log the depth that they're at, log the size, and if you see something interesting, they can sort of head off in that direction if it's not, you know, without width of the scope of that sort of expedition ROV adventure, which I just think is so cool. And I implore you all, because I couldn't work out if I don't think I have the rights to be able to share it in this YouTube video, so I'm going to put some links in the description down below. Go and check out some of these ROV footages, because it is incredible. I could spend hours watching them, and maybe if you're interested, I'll do a whole art video, because I'll be able to draw from them, and maybe we'll draw some cool ROV footage, because it is just spectacular how awesome the species that they are finding are. So there are 5,000 known inverts in the Arctic that we are seeing from either those grab samples or things in ROVs, and I imagine that the number is going to keep increasing, because we really, like, it's one of the least studied spots. Like, it's really getting, like, it is well studied, but it's expensive and expeditions are difficult, and we haven't looked at, you know, all of these different spots that are all around, and it's just really cool to see organisations like Ocean Census. Their job is to like go out and just discover all these new creatures and log them and record them, and just seeing how many they're like discovering each year is just so exciting. Exciting is a word a lot, and I worry that people think that I'm just saying exciting, but I really am so excited all the time. It's so exciting. Living in the Arctic are things like crabs and lobsters and bryozoans and sponges. You get deep sea soft underwater corals in the Arctic, which is so cool. I love the fact that you get a deep sea coral. They feel like the dark horse of the coral family. They're like, leave me alone. Like, yeah, the tropical ones, everyone's there, they're ranting about them. Just leave me to my dark, cold dungeon. And they're just beautiful and gorgeous and so understated. Ocean Sensors actually discovered in 2024 a hairy decapod, which is like in a group of crabs, or it's like a hairy shrimp, it looks like, but the hairs are actually bacteria, because this hairy decapod was living on a hydrothermal vent, which is really cool and just such a unique environment, because that's sort of where the either where the tectonic plates are or hotspots are moving. So the energy from hydrothermal vents is not coming from like the sun, because they're really deep on the sea floors. It's coming from that under the earth crust sort of energy, and it's spewing out quite a lot of the time toxic stuff. And this shrimp has made these little bacteria are turning like toxic hydrogen into their energy. Like, that's how they're surviving. That's so cool. That is a little way souther. Well, everything is south of the North Pole, isn't it? But it is a little less under the ocean sensors. Also found at 2,461 metres, a snailfish. I love this fact because snailfish are one of the deepest sea fish. I think they might be the deepest sea fish you can get. And I also found some rock pooling, not the same species, but the same group of species. And I just love that they're literally from the bottom of the ocean to where you can see them, like just at sea level, if not a bit above. Like, that's really cool. That snailfish had long barbels to help detect movement in the water, because at 2,461 metres you are going to be in pitch black darkness. In terms of fish, I can't not mention Arctic cod. That is a really, really important species in the Arctic for food chains, and is probably one of the most common fish up there. And Arctic cod really utilise the ice. Cod, their whole lives are tied to the cycles of the ice and the Arctic. They time when their larvae hatch with the melting of the ice, so that when they hatch, they can use that energy from the ice algae to sort of grow and be successful. And they spend the first 2 years of life really close to the surface of the ice, and using that as sort of protection as they grow. A lot like you maybe would hear in rock pooling in the seaweeds, where you find lots of like juvenile cod. Their version of that up in the Arctic, up in the North Pole, is just like sheltering up and near the ice. And of course, I have to mention the Greenland shark. The Greenland shark is one of the longest living creatures, if not I think the longest living animal on the planet. They can live up to 400 years, and they are huge. They are 21 feet. That is like twice as long as the thickness of ice at the North Pole. Again, 10 feet is not a lot. They dive down to 2,000 metres, which is a massive, massive feat. Like, that is just so deep. But they also must take them ages. They move at an average speed of 0.3 metres per second. That is so slow. That's so slow. I really wonder, if you're living 400 years and travelling that slow, do you think you're living like a normal, and I say normal because every animal lives a different amount, so let's just go, instead of normal, a human length amount of time. Do they feel time passing at like the same consciousness level that we do? Are they spending 400 years like really contemplating everything they know about sharkness? Like, by the time they're 400 years old, are they like really wise about the Arctic and what goes on up there? Or are they not really aware of it and they're like, we just keep going? Do they think that everything else is like a fly moving really fast? I'm so intrigued. I mean, it would be such a weird creature to swap brains with today, wouldn't it? But the thought that I'm going to end this video on is that the whole way that I've gone through and just looked, I mean, I've really just skimmed the surface of all the incredible things that we know about the North Pole and the Arctic. But thing that comes up a lot of the time is just that we just still don't know as much. Like, we're still learning all the time. There are still so many discoveries to be had in this area and in the ocean in general. And like, I've taken this, I read, so a working group in marine science is when you get a load of experts together and you all agree to sort of regularly meet up and decide the direction that maybe you should all focus your energy on, or that people should work on, and you can put your expertise together to put out sort of reports to be like, hey, this is what we know, this is what we don't know, just so that no one's like overlapping. You know, you want to make the most of your energy and your resources when you're working on something that costs a lot and go on these expeditions. And this is from 2011, so like it is a while ago, but I found the working note documents for like a working group notes. So because I came across that, I just wanted to share that like the first question up there was about the discussion. It was like, when are organisms incorporated into ice? And then another one was like, the life cycle strategies of key diatom species, which is like a little sort of algae-esque creature, is like, are yet unknown. Do they rest spores? Do they have dormant states? Like, that was in 2011. This is a key player in that sort of like phytoplankton, diatom making energy from light world. And in 2011, we're asking the questions like, we don't know what their life cycle is. That's like the start of many of the discoveries, right at the start of like many of the things you might learn about a different creature. And I'm not saying this to be like, oh, I can't believe we don't know this. It's the exact opposite tone of that. It is so incredible because there is just so much that we don't know, and just goes to show that we need voices and people and you out there with your thoughts and questions and mind and curiosity to come along and to voice your love for the oceans, firstly, to say that this is important, to say, hey, we want to know, we think it's really important that these species are here, because I won't dwell on it too long, but you know, if we don't know what species are there, if we don't know those key facts about the life cycle, we don't know how the effects are gonna be affecting them. How many species are we losing before we even know that we've lost them? And things like this are just so crucial. And also, if you're there, whatever age you are, and you're looking to be a scientist and you're finding that this is interesting, yes, marine biology is competitive. Yes, on those ships there is not a place for everyone, because otherwise, you know, it has to be a select amount of people. But that does not mean that you do not deserve to go into that space and to have those thoughts and to have those ideas and to become a scientist if you want to, and to go out there and do the research or share about it, or just have a chat with someone and say, hey, have you seen this video about the Arctic? Did you know these facts? I'm going to go and learn some more, and please tell me them, because I could just talk about this forever. So I want to hear all your fun Arctic facts too. But that's what's so exciting about marine biology, about learning about the creatures in the North Pole, about all of this different stuff, because we are really still at the start of this learning journey, and every year more and more is happening, more and more is excitement is going ahead as we learn more, as we develop new techniques, as we share that love and excitement for the Arctic. And I truly do believe that is the way that we are going to help protect it. The more we know, the more we fall in love with it, the harder it is going to be to ignore or add to the issues that are going on, and we can turn it around. And that is how we're going to end the video, on that positive note. Thank you everyone for watching. Please like and subscribe, and check out my Patreon if you want to know more amazing creatures about the Arctic. And you can also on my Patreon sort of pitch areas that you want me to learn about. But if whatever thing you celebrate in this festive season, I hope you have a fantastic time. And if you're not watching this around Christmas, I think Christmas films you can watch all year round. So put on Elf, because that, I am declaring that now. That is marine biology research. Bye everyone.